Hello and welcome back to What Exactly. In the previous video, we understood the basic intuition behind transformer and we also understood self-attention. In this video, we are going to discuss about multi-head attention. Okay, before getting started, let us understand what is a head. In the previous video, we discussed about self-attention. So let me show you the self-attention. So we found he is a student and we had different matrices Q, K and V. And when we multiplied with different weights we got this vector. So this is called a single head. But actually let me tell you what is the intuition behind head and what will happen if you have more than one head. So what is head? Simply we are multiplying q, k and v. We are doing the scale dot product and we are doing some mathematical operations and finally we are getting the output, which is called a head. So what is the intuition behind head? Like, assume that head identifies, like if we are having more than one head, like let me show you. If you are multiplying with different weights we got a different head, and if we do the same thing thrice we will get three different heads. So these are multi-headed attentions. So let me draw the intuition behind what multi-head attention. See, initially we have embedding vector x1. We multiplied with some weights, we got q1, k1 and v1, q2, k2 and v2 and so on. And we are doing some mathematical operations to calculate the head. Okay, what if we multiply with different set of weights, which is w2? We'll be getting different query vector, key vector and value vector. We'll be having different query key and value vector for each and every embedding. So we'll get, when we do mathematical operations we'll get a different head. So we'll be having head 1, head 2 and head 3 for three different weights. So what is the significance of these different heads? Assume that your one head is calculating, or one head is finding the answer what is happening there, and one may head also find where it is happening. It's just for intuition I'm telling. Suppose you are saying I visit Africa. So one of the head may answer the question where you are visiting. Like, these heads are different features, like how we calculate feature by by getting different weights. These heads are the same thing. So understand the intuition why we are using heads. Okay, this is about heads. So whenever we are having more than one head we'll be calling it as multi-head. The simple thing what we are doing is, instead of multiplying with w1 matrix we are multiplying with a different set of weights to get a different head. Okay, let me show you the transformer architecture in detail. In the previous video, we just gone through the overview. Let me explain you. See, this is the French to English conversion. This is from the famous blog. I have extracted the photo. See, G Swiss Eduent. So what happens is we are sending this input. It goes through six encoders. This is a hyperparameter again. You can change based on your network. So after going through these six encoders, we'll get final output. Okay, this vector is passed into each decoder. Okay, we are passing this vector into each decoder, and we are sending a start of sentence token. So based on this, we are calculating output. So whenever we are sending J Swiss student, I mean event, we got some this matrix, and we finally get this output, and we get end of sentence token. Okay, let me show you multi-head attention once again. So we are here with multi-head attention. So we'll be having query, key and value vectors. In TensorFlow we have a function which is called multi-head attention. So you can directly implement our multi-head attention using this function. But let me explain you what we are doing in multi-head attention. We are doing qk transpose by root dk. We are softmaxing it and we are multiplying with the value vector. This is what we are doing in a single head, right? So we need query, key as well as value vector. And if I go through the decoder part, see here, from here we are extracting a vector, right? So this vector is passed as a key and value in the decoder. So in order to calculate the self attention, we need query, key and value. So when we are doing multi-head attention, we'll be having two multi-head attentions here. One is called masked multi-head attention and the other is normal multi-head attention. So in masked, I'll be telling you what is masked multi-head attention. In the other multi-head attention, we'll be passing query, which is the decoder output, and we'll be passing the encoder's output here. So whenever you are calculating the correlation, as I told you in the previous video, so we'll be calculating the correlation between decoder's output and encoder's output. We'll do all mathematical operations and we finally multiply with this encoder value, and we'll best it's better to understand that, see, this is a hidden box. We are sending encoder output. We will be getting a decoder output. So based on some mathematical calculation, it understands the relation in this input and it will give me the decoder output finally. This is the basic understanding of transformer networks. And if going through this series, you'll be getting a better understanding of transformer networks. Okay. So let me tell you, draw the intuition behind attentions. So why we are having different attentions. This is extracted from a famous blog. So initially, when I take a single attention with some weights, see, I got the animal did cross the street because it was too tired. Okay. So what it represents here? Is it representing the street or animal? So initially you can observe that these tick lines in the sense these are weighing more for the, okay, the and animal. So with one set of matrices, we are paying attention to the and animal. And suppose we are having different head, we are using different weights. You can observe that we are paying more attention to the word tired. As I told you previously, these draw the intuition, like just for the sake of understanding, understand that one head is answering where it is happening, one is answering where you are going, something like that. These are respective for the model itself. So while training, it understands the patterns and it will uh, know why we are using w1 and w2. Okay. So this is the intuition. This is also extracted from the famous blog. So here they have taken two words, thinking and machines. So this is our embedding matrix. This is our embedding matrix. So we will be having Q0, K0 and V0 as query key and value pairs with different matrices. W0, W0, W0Q, W0V, K and W0K. The same thing here. We will be having Q1, K1 and V1. So with different heads, we are calculating different, with different ways we are calculating different heads here. Okay. See, suppose you are, as I told you, number of heads is a hyperparameter. So suppose I am choosing 8 heads. So I'll be getting 8 different set of matrices. So let me denote it with Z naught. Okay. And the main doubt you get is, see, when I pass it to encoder, like initially, suppose my embedding vector is of size 512. And these are repetitive blocks. These will be having the same architecture. So if this is taking the size 512, this also must take the size 512. This also should take the size 512. The same thing happens. But whenever we are doing the multi-head attention, we'll be getting different matrices. So what we do is we finally concatenate all these Z0, Z1, Z2 and Z7 till Z7. We'll be concatenating all this and we'll be multiplying with a matrix WO. This is understand WO as output matrix. So we'll be multiplying with these weights in order to get the output of length, sequence length, max sequence length by embedding size. This is the input size which we are giving for our model. So whenever we multiply, we will concatenate all these and we multiply with WO in order to get the size 512. So this is a hyperparameter. You can change, you can use 128 or 256 or any other thing. The basic idea is we are concatenating the output from all the heads and we are multiplying with WO and we finally get the output. So this is the bit maths behind multi-head attention. But whenever you are using the Keras framework, you can directly use multi-head attention, and it will be taking three inputs as well as a mask. Okay, I'll be telling you mask in the later video. Just for now, you understand what we are giving the inputs. We are giving three inputs. Okay, one is query, key, and value pair. Okay, this is so it will implement us multi-head attention. So before calling multi-head attention, you must create the class of multi-head attention. So it will take number of heads as input and embedding size, which is key dimension. So if you are giving these two parameters, suppose you want 8 heads, just create a class of multi-head attention by taking heads is equals to 8 and key dimension. Suppose you want 512, you can just write 512. And whenever you want to apply it for input, see I created an instance with name A. So I can write A of input 1, input 2 and input 3. This will give me multi-head attention implementation, and finally I will get the output which is of size 512. As I told, the multi-head attention will take care of multiplying all these with different weights, concatenating it, multiplying with the weight matrix, and finally getting the output which is of size 512. This is the implementation of multi-head attention in TensorFlow. So let me recap everything what we have done. See, initially this was our sentence. This thinking machines will embed each word like thinking and machines. We'll multiplying it with different weights. See here he has taken 8 heads. So we'll be multiplying with 8 different weights. W0, W1 and so on up to W7. We'll be multiplying with all this. We'll be calculating query, key and value pairs, and okay, and we'll be getting different outputs which is heads. So we'll be getting z0, z1, z2 and z7. We'll be adding all this, we'll be multiplying with the output matrix, and finally we will get the output z. And you can observe that here we have 4 by 2. So actually here one block is of size 64. So 512 is represented by 4 blocks. Okay, so the same output we got as input. So this will be fed into another encoder layer and the process continues. This is the end of this video. Thank you.